Okay, so to help you with some of the homework problems, I'm going to introduce you to an object called an electroscope. I didn't get a chance to show you in class. So an electroscope is a device that can hold charge, and you can do some tests with it to test whether it's positive, negative charge, or neutral. So if you go to page 6, or the second page of your homework, number 6, you will see 5 different states of an electroscope. Okay, and you are told what states they are in by the charge signs, and I've also labeled them polarized. Just cross out the word charge there. Positively charged, negatively charged, polarized again, and notice that the polarization is different. You got negatives on top here, positives on top over there, and then just a neutral one where I've designated with one positive, one negative in each one. Okay, so let me explain what I showed you one in class. I remember now. It was one that looked like this. It was like a ring, and inside the ring was kind of like an S-shape support, and then there was a little needle there that could be deflected. So the electroscope that you see here is a different version, but it's the same idea. We have a sphere, right? It's a metal sphere, and inside the sphere is a conducting rod, and you have these little gold leaves, or I should say foil. Okay, it can be made of gold, aluminum, whatever. And so if they're just not charged, they will hang straight down, or more or less straight down. And then if you charge them, or induce a charge on them, then when they become charged, they repel each other, so they're splayed apart like that. So when you see the splayed apart, you know it's charged. It's just an issue of which charge it has. Okay, so in the homework problems, you have situations A through F, where I describe what's going on. You got to tell me which electroscope reflects that. So I'll do the first one with you. Okay, so let's say I have a positively charged rod. Okay, we don't know how it became positively charged, but we just know it's positively charged, is brought near, but does not touch an electroscope. Okay, so you got to put a few things together. If I want to charge the electroscope, right, the two situations where it's actually charged, this one and this one, we're either going to charge it by conduction or induction. If you recall, conduction means that we literally touched it with a charged object. Well, we didn't touch it here, so it can't be conduction. The other one is induction, which is we use the rod and some other methods to induce an opposite charge. But this doesn't say it was charged by induction. All it says it was brought near, but doesn't touch. So that screams polarization. Okay, we showed in class where if I bring a rod near something, I can make it attract or respond without actually charging it. And then when I take the rod away, it goes back to normal. So the question is, which of the polarization electroscopes reflect this? Well, if I bring a positive near the electroscope, it's going to attract negatives. So the negatives are going to come to the top, so it makes sense that D would be the electroscope that shows this. The negatives are brought to the top, leaving the bottom positive, and so if the positives are concentrated here, they're going to repel. It looks like it's charged, but it's not really. Okay, so with that in mind, you should be able to do B, C, D through F. Again, it takes a bit of thought to do this, but you should be successful.